Good morning, everyone, and welcome to this Connected Workflows webinar. My name is Jonathan. For those of you who don't know me, I'm based in the UK with Graitec. I'm a customer success manager on the structures team, and I'm also Autodesk Expert Elite. You've got my Twitter handle and my email address. I will show all again at the end of the webinar. So today is about looking at the connected structural workflows. Here in the UK, we get constantly asked how to connect different disciplines and different software. So today I'm going to take a run through Revit, Advanced Design, Advanced Steel, and how these softwares can connect, and we can pass information in a BIM workflow between them. So what we're going to look at is Advanced Steel, and then we're going to link that into the Advanced Design module, and we're going to design it, and then we're going to link it back through to Revit, and then we're going to link the Revit model back through to Advanced Steel and vice versa. So we're going to synchronize a lot. We're also going to look at some analysis and some steel connections, incorporate it with the Graitec Power Packs. So it's basically just a workflow to show you that this is all possible and how you can sort of bring this into your everyday project. And at Graitec, what we're trying to do is multiple platforms for multiple workflows. So depending on what software you have, we think we can help and develop a workflow for that. So quite a short PowerPoint, and I'm going to jump straight back into the software. So you can see at the bottom of my screen, I've got Advanced Steel open, I've got Revit open, and I've also got Advanced Design. So I'm going to take a different ploy today. I'm going to actually start the project in Advanced Steel. You can start it in Advanced Design, you can start it in Revit, and the interoperability and the workflows all sort of synchronize round through them all. But I just thought today I'd put a different spin on this to show you the workflow. So I'm going to start with a blank project file, and I'm going to do this in all the software. So I'm not going to have a pre-prepared model. I'm going to sort of take my chances and do everything live in the system. So I'm going to start with Advanced Steel. I'm going to put in a very simple portal framed structure. So the first thing I'm going to do is just going to save this file. So I've got a folder on my desktop already pre-prepared, and I'm going to call this the AS file for Advanced Steel file, and I'm going to simply put in a very quick portal frame building. I'm not sure what has happened there, so we go to start point. And we put in a really simple portal frame. Now this sort of webinar is not about each individual software, it's just showing the information passing through between them. So I'm going to go pretty quick in how we set everything up. So I'm just going to put a 12-degree pitch. I'm not really going to change the sections, I'm just going to leave everything as is. And then I'm going to transform the elements. So I'm just going to take a complete copy of that. I'm going to create multiple sections, and then I'm just going to draw in some tie beams between the components. So I'm just going to actually change that down to a smaller size and say that that indeed is a beam. I'm going to copy it across to there, and then I'm also going to just create a multiple copy of them. Again, you could use transform elements or the array tool, but I'm just going to go with something like that. So it's a very simple frame put in Advanced Steel very, very quickly. Okay, so the first thing we're going to look at is I'm immediately going to put this out to Advanced Design because I want to run the analysis and the design check on it. And I'm going to use the Advanced Export, and I'm going to quickly hit Advanced Export. And you'll see that it also warns you once you export the file that it asks you, do you want to keep the model the same? So in some cases you will probably always hit yes. And then if we just check our Windows Explorer, we can see if we go to the desktop, you will see that no file has been created. The reason for that is the export generally works in advanced steel once the numbering has been run. So if we run the numbering on the project, you will see that each individual get a number for the columns, rafters and beams. Then if we run our advanced export, you will then get your SMLX file. So a big common mistake that lots of companies come to us with is that it's not exporting. Usually it's down to the model not being numbered. So make sure that the model is numbered prior to exporting. So a very simple frame. We will add a lot more detail to this once we sort of pass it back and forth from Revit and advanced design. So once the model is like that and I've exported it, I'm going to jump straight to advanced design and I'm going to go to a new project. And this is our advanced design window. So the first thing I'm going to do is go to the BIM tab, and then I can go to the import section. And I can say simply import. And it says, do you currently want to do it in this model? We're going to go yes. And then it pops us out to find the actual file that we export. So if we go to my desktop, find the file, you can see that we find it. We change the file type to SMLX. And there we got this file. We click open. And what it's looking to do, it's basically got a material in advanced steel, which is S275JR, and in advanced design it doesn't recognize that as yet. So what we can do, I can assign that material and I can pick one from the list. So I can say that I want the 275, click assign, and it's just material mapping the sections across if they don't actually meet between the two databases. So you can see that it has imported something, but if I just orbit the model, you can see if I go to the home tab and just turn off the grid, you can see that it has taken all the information that I've drawn in advanced steel and imported it into advanced design. So what I'm going to do now is run a quick calculation on all this. So we're going to need to do a little bit of work in advanced design because, as I said, it's all from scratch, so I don't have anything pre-existing. So the first thing I'm going to do is look at the loading, and I'm going to create a load case for the dead load. And we have a look at that, and you'll see under the self weight it will have a -1. So that's pretty much what we want. If we look at the structure, you can see that everything comes in. But I'm going to create a substructure in here, so I'm going to go subsystem. I'm just going to go to footings or footings if we So I've added a new subsection. This is where I'm going to put in the the rigid points for the base plate, so I can actually know. So I'm going to put a rigid point in there. I'm going to add one to every column element. I think I missed one, which is there. So once we do that, I can then select them all in the window, and you can see that they're currently affixed, but I want to change it to a pinned footing, and you can see that all the loads will be there. We've all got the rigid points, so that's the point loads down at the bottom. I will then select each of the rafters, right click, and I can go loads on selection, and I can simply add in a -2 kilonewton load on the Z direction, hit escape, and then we just go loads auto scale, and you can see that I've now loaded the rafters as well, which will then transfer down through the columns. I'm going to right click on the loading again, create a case, and I'm going to add in some wind loads. So once we've got the wind load, we can actually look at the region, so the wind speed region, and we can select it, and because I'm based in near Oxford, I'm just going to click in here, and there we have the wind load on, and then I can right click and I can automatically generate the loads. So once we've got the wind loading, we can then put in the area loads. So this is where we just put a layer load around each face of the building. So I'm just selecting each one individually, and I orbit the model around just to select each section, and then I'm going to put an area load on the roof as well. And there's all the area loads on. Then we go to our combinations, and we go to properties. We go to a very simplified combination set that adds them in there. So again, a very quick generic run through of advanced design. We're going to go to analysis. I'm going to do a quick steel design, click OK, and the system will go off and engineer and do the analysis check. So we can have a look at some of the processing. So if we look at our forces and XZ, as you can see, it has decided I have lots of deflection and lots of errors and bits and pieces wrong. But again, I'm not here to fully solve. I just want to show the process. So once we get to this level, I could save the view. So I've got it as post-processing. But what I can also do is now start to export this information. Right, so I'm just going to go to export. I'm going to export it as an SMLX AD, and I'm going to call it the AD out file. So that's sending the information out to an SMLX file, and we simply click OK. Okay, so what I've done is drawn it in advanced steel, exported it out to advanced design. So I'm going to change tact a little bit. I'm now going to introduce Revit into the situation. So instead of coming from advanced steel to Revit, I went to advanced design. I'm now going to take this model from advanced design into Revit. So I'm just going to start with a structural template. No sort of smoke and mirrors on this. This is the default Autodesk template that comes with Revit. And I'll explain a little bit further that there sometimes is the need to be a little bit of configuration in the template to get things to work a little bit smoother and better. But we're going to just show out of the box what we have. So there's different ways. So if I go to the add-ins tab, I can actually use the advanced steel extension to import the information because it's actually looking for the SMLX file. I can also use the Graitec BIM Connect, but just to show you what comes out of the box, so I can just go import, advanced import, and it will allow me to browse to my file. So I'm going to click my desktop. I'm going to take the AD out file, and just to show you that it is today, 22nd, 10/13. So 1 minute ago that file was created. And I then click open. So you can see in Revit we've got a view of the columns, and that's because obviously we're in a level 1 plan view. And I just got a quick message about the audio connection. I'm not quite sure what. Now I think there was a quick problem with the internet dropping, but all seems to be back up and running. If you may have missed it, what I've done is I have exported the advanced design file. I went to Revit and I've used the advanced steel extension, and I've imported the project, but obviously we're in a structural plan view, so I'm just going to go to a 3D view, and you can see that I've got an analytical model. I can turn it on and off, but you can have a look at the analytical model and you can see that it has brought all the loads. So it's got my load from my rafter. If we look at the Analyze tab, you can see under the load cases that it's brought in all the wind loads and all the dead loads and the live loads. So everything that we've put into Advanced Design automatically has then come across through into Revit. So I'm just going to turn off the analytical model, and I'm just going to make this a little bit easier to see. So I'm going to go to a shaded view, and I'm going to go to fine detail. Now what you will find is in the standard Revit template, the display is not really very good when you import content. So I'm just going to quickly override the graphics in the view, and then you can save this as a view template. So I'm just going to go to surface pattern. I'm a bit of a geek, and I've got my favorite color scheme, which is a homage back to the advanced steel colors that I tend to use. I'm going to go 20% transparency, and I'm going to apply and OK that, and select the rafters, override graphics and view by category, and again the same process. I'm just applying a better visual style because I don't like the dark one. I'm just going to change it to 26. So it's a little bit easier for me to see. So what we have is the model, which is fully loaded as well. So we've taken it from Advanced Steel to Advanced Design and then imported into Revit. So I've only had to draw it actually once, but I've been able to use the same file within 3 different softwares. So now to take this a little bit into sort of the Revit platform, and what seems to be happening more and more with our customers in the UK is that they're starting to look at the structure tab and they're looking at the connection tab. So sort of in Revit 2017, this was introduced that we can have the ability to add a structural connection. And for those familiar with Advanced Steel, they in fact typically are the Advanced Steel connections that have been ported across between the softwares. So as I said, there's lots of things you can do in your template prior to starting it. When the big thing is have the connections preloaded, because then they're sitting within the project browser. So if I click this little down arrow for the connection settings, it allows me to preload standard connections that I like to use. So I'm just going to go, well, usually I will put a base plate in. I will put a haunch plate, and you can actually see by the groups you can actually filter them. So if I want to go platform beams and I want to go single sided end plate, double side with a safety bolt, I want beam end to end, I want an apex haunch. So I've got a base plate, I'm going to put a haunch detail in, I've got the apex haunch, single sided end plate, and I'm just going to click OK. You can load them all in, just makes it a little bit slower, but I'm just going to go with these. So I select a component, go to the structure tab and simply click the connection button, and you'll see that it will put in this little connection symbol. I can then select from the type properties and then just apply the connection, and Revit is smart enough to know the type of component that you've selected, and you will see there it's simply put in a connection. What I also like to do is I like to override that as well, and I choose that color and I go solid, and I don't put a transparency on it. So I've got my blue plate, and the beauty of Revit is that I can just select that base plate. I can modify its parameters, but I'm not going to on this occasion. I can just go copy multiple and copy from there, and you can just click points close to the base of the columns, and Revit is smart enough to find and know that it will put them into the correct position. So I've added that in. I can select this rafter in the column, structure, connection. We have a little look at that. That looks okay to me, and then you can select it, copy multiple, and we just place that along there. Unfortunately, you can't copy it to this side. It's a different orientation, so we have to put a different connection in on this side. And again, we'll just do a multiple copy. And then we can finish it with the apex. So the structure, connection, and then we have the apex haunch.
Sometimes it takes a second or two graphically to show. I'm just going to go to modified parameters because in this location I don't like the way that it's done. One is different, so I'm just going to go none. And then the bolt groups, I don't like. I'm going to change them to 3 bolts and then 1, 1, 2, 5 probably, and I'll set that out to 50. So I've got 3 at the top and 1 down the bottom underneath in the haunch. And then we select this and we can go to copy from there and then just place it at the apex. So you can pretty much do what you can do in advanced steel, obviously, with the Revit connections, if you know how to use them. So I'm just going to leave the model like that, and I'm going to take this model because I've added a bit of content in Revit, and obviously that differs to my advanced steel model because there's extra connections in. So then we're going to go to the add-ins and the advanced steel extension. One thing to look at is the settings section. So this is where we can control what's imported and what's exported. It's just be aware that there is settings for whether we export the beam shortenings, whether we import only structure or we export only structure, whether we want to export the grids based on views. There's lots of different configurations and different settings that you may use, so just be aware that they're there. So I'm just going to export this out to an SMLX file. So it's my RVT out file, and then I click save. And this may take a second or two just to create the file. And then we'll go straight to advanced steel. So now we're back in advanced steel, and we've sort of went full circle round to advanced design, then to Revit. We can now start to synchronize the changes. So rather than import a complete model from scratch, we can actually use export and import and then synchronize. This allows you to obviously check for the changes. So we look at the RVT out file, so it's 1022, and we click open, and this has found a full range of changes. So you can see that some of the beams and columns, the material has changed because remember we went to advanced design and we specified a different, so it was an S275 rather than S275SJ. So there is a material change, and then it's found that we have all these connections. So if I just take everything and I go apply all actions, it'll take a little second, but it should update the model. And you can see there it's flashed where it's immediately put in all the connections. So if we close it down, you can see that the beauty of the system is that if I put a connection in Revit, when it comes into advanced design or advanced steel, it's actually the same advanced steel connection. So if you're familiar with advanced steel, this will be pretty standard stuff. So you can see that the connections we put in Revit automatically sync across into advanced steel. So I'm going to add a little bit more content into the advanced steel model. So I'm just going to go to my UCS, stick it on top of the rafter. I'm going to draw a simple I-beam section in and just put it as a beam. I'm going to manually move it down 500. Do similar on this side. Start my connection vault, and I go to probably a single-sided end plate. To there, I'm not really that worried about the type of connection. I'm just going to sort of make some changes to it. So I'm going to take a copy of that. Put that in there, reset my UCS back, and then I'm going to actually position the UCS. And we'll rotate that round to there. I'm going to put in a bracing section from there to there. I'm just going to change it to a very single, and let's go with a flat. We'll go with something pretty simple, say 50 by 5 is good. So something like that. I like to just offset it. Let's say 300 from the top. standard from the bottom. So let's leave it there. We can add a connection to this if we wish. Let's go to gusset plate 1 diagonal and just do a very simple connection. You can see I've added some more content to the model, not done a huge amount. First thing I'm going to do is go to numbering, so the numbering is up to date. So it's updated some new components. I'm just going to hit save my model, and then I can now export that back out into Revit. So I'm just going to go, it's my advanced steel file, but I'm just going to label it 2. And we can now export that out. Again, prompts me, do I want to save the model? Yes, because I want the model file to be the same as my exported file. I can then jump back into Revit, and then I can synchronize them changes back into Revit. So the process is the same. We go to load, AS file 2, we click open, and you can see that it's found lots of changes again. So I'm just going to take everything and apply it. And this is where you get, obviously we've added a new bracing, and because the project browser doesn't have this family, you have to manually select it. So we can go and look at this, will load in what's in the project browser. So if we go to family, we can see that we don't have a flat section. So we just go to load family, and the actual location for all the Revit content is project data, Autodesk or VT 2018 Libraries UK, and then we go down, we find structural framing, and we go to steel, European Pacific, and I've got a new family which Autodesk have released called flat bars. Select it, and this will bring in all the flat bars that we have in the Revit. You can see they've done quite a lot, so they've mapped the exact same that sits in advanced steel. So we just have a look for 50 by 5, which should be there, and we select OK, and then we can select that from the family name, and there we have our mapping. We select OK. Revit will sometimes give warnings that the brace is slightly inaccurate. That's because the pitch of the roof, and Revit doesn't really like the 2 decimal places, but it's not an error, it's just saying it can be ignored. It's slightly off the Revit axis, so we can just simply click OK to that, and it will go and append these changes into my model. It takes a little bit of time because it's going through all the connections and just checking everything to make sure anything has changed that it will update. And then once it's done, we can simply close it. And we have a little look around our model. You can see that the tie beams have been put in. We have a little look down at the brace. And you can see that is then taking all the changes across. That pretty much is where I'm sort of going to get to today. It's just an idea that you can start to pass all this information between advanced steel, Revit, advanced design. So even at this stage I can then pass this model back out into advanced design, synchronize the changes. And again, what we find is most companies have a varying workflow. What we try to do at Graitec is just help you along that process and identify the key stages, and just formulate that into a proper workflow of that allows you to work, whether you're working with an FEM package whether it be advanced design, robot, whatever it may be, whether you've got a BIM requirement, whether the client's looking for an RFA output, whether you're going to a fabrication level with advanced steel. However, we at Graitec can help you along that process. I'm just going to show this screen again. So if anyone wants to contact me or reach out to me for any advice or help on how they can achieve this, or whether they're having issues with the transfer of information, just to identify the key stages, just contact me by email. It's jonathan.hand@graitec.co.uk. Find me on Twitter, ring any one of the Graitec UK offices, just drop me an email. We will follow up with most of the people on the list. There's a few Graitec people which are just sitting in as well, but we will follow up with everyone. Has anyone got any questions they want to ask me to look at? I can unmute people if people want to join the conversation, or you can actually just type me.
Can you book that one?
So has anyone got any questions on what they've seen, or did they miss anything? Did there seem to be an issue with the internet at one stage? So as I said, I'm going to probably end now. Just drop me an email or shout out on Twitter, or contact any of the Graitec offices for any help or assistance. We run these webinars sort of every 2 to 3 weeks. If anyone's got any suggestions for what they would like to see me do in future, or recover stuff, or focus on something a little bit more in depth, just let us know. We'd be more than happy to explore it, to help you. So thank you very much for attending today. Just look out for more of the webinars upcoming. I know we've got a few more in the next couple of weeks, all around the structural workflows, with connections and connected design. So thank you all very much, and I will see you soon.